Hi, welcome to an introductory video showcasing the use of icon-based smart contracts with Atlas. My name is Ilia Rodionov and I'm a delivery manager at MLabs. In the milestone 4 of PSM Catalyst project, we re-implemented the on-chain script from the betting example using icon language. This work demonstrates that the whole unified test suite can be used without any changes, including the off-chain code of the application. Our first step was to make sure that already defined types for script parameters, datums, and redeemers can be correctly understood by icon scripts. In icon, you can use only so-called non-opaque types on the boundaries of contracts. Those types have only one canonical encoding and usually represent simple type like an integer or a container type like a list. On the other hand, opaque types cannot be used in datums and redeemers, since icon compiler has no information on how to decode them. Some of opaque types belong to the standard library, for example, the type value. That way, all user-defined types that make use of opaque types become also opaque. So we can't use value at the boundary, but instead, we can use a structural counterpart. Hence, in the type of for datum better of datum, the field previous bet is defined as a nested map from policy ID to pairs of asset map to integer. Opaque types might be useful in the internals of contracts due to invariants they can hold. In order to use them, one have come up with two sets of types, one for the boundary and the other for the internals, and do all the munging for them back along the way. For example, when we did calculations over values in the bets played, we used a function from asset list that takes a structural type value into an opaque value. For this, we defined greater or equal operation in the style of Plutus checks. Getting back to the compatibility with the original protocol, fortunately enough, the mentioned structural representation for value was exactly identical to what we used before in our reference example based on Plutus tags. To give a less lucky example, let's take a look at the datum type again. The other field for a list of bets was defined as a list of tuples of pubkey hash and oracle answer datum, which is just an integer. In icon, there are two possible ways to encode a list of tuples, but sadly, none of them could express the encoding used in the original example. The reason was that in Plutus TX tuples were wrapped with Plutus data constructor cons, and this is not covered by options provided by icon. The fact forced us to introduce an additional type bbet, since a new type is what corresponds to the Plutus data constructor cons. There might be cases of more complicated encodings when a suitable combination of structural non-opaque types cannot be found at all. In those cases, the only way to go is to use data type that represents Plutus data as it is, and tear out its parts manually using its constructors until the point you get the bits that can be represented with non-opaque types. Then you can just cast the untyped values into the target types. We again were very lucky here, since just by introducing an additional type, we were able to get the representation which was fully compatible with what we have in the reference example. Mind you that this issue becomes topical only for cases when a protocol based on another language like PlutusTX or Plutarch has been already launched and is in use, so you just cannot change the way data is encoded. Also, using of data as a boundary type has a detrimental effect of almost making blueprints useless. So we got all the types right, and we proceeded with implementing the logic of the contract and compile them. Icon supports blueprints from CAP 57 and produces detailed information about the validators, including the structure of parameters, datums, and redeemers. In the nearest future, Atlas will get the support for blueprints natively, and one will be just able to use a short template Haskell code to generate types and their encodings automatically. For now, though, you have to get your hands a bit dirty to load and use a compiled validator from an external source. In Icon, we can use icon blueprint convert command to produce an envelope that is compatible with Cardano API. This envelope file should be available in the Atlas project. Once here, Atlas provides read validator action that can load it, producing a validator. In order to apply parameters, you have to recover the UPLC code using unchecked deserialized UPLC function. Since the encoding for script parameters have been aligned, we can just use toData to reproduce encoded Plutus data and apply it as a constant value using make_iter_up function. The result can be turned back into validator using a couple of functions. First, serialize UPLC, and then validator from serialized script. The upcoming update to Atlas mentioned earlier will smooth out and secure this tedious and potentially error-prone process, bringing up the ability to load the script directly from Plutus contract blueprint, as well as to apply parameters based on generated data types. Let's run the test suite with the icon contract. It shows that everything works correctly like it worked before with Plutus Jack script. The source code for the icon-based validator can be found in bet.ref icon repository on GitHub under MLabs Haskell account. The Atlas example currently can be found in the PR 358. We are waiting for your comments and thoughts in a recently created Atlas channel on Genius Yield's Discord. Thank you for watching and happy hacking!